Hey folks, Mr. Dell here. We are looking at determining whether, given a couple points, either one of them or both of them is the solution to a system of equations. So this is this problem specifically I'm taking from CPM course 3, and this is section 6.2.5. And it is asking us to actually point 4. I'm sorry, wrong section. There it goes. 6.2.4, and it's 6-81. So it wants us to let's read it. So it says Hannah thinks the solution to the system below is -4, -6. Wirt thinks that the solution is 20, 10. So this is the solution. This is the system. So Hannah thinks this is the solution. Wirt thinks that this is the solution. So A is the question is Hannah correct? And B is Wirt correct? So what we need to do is determine if either one is correct or both. We'll determine that. Knowing that we have a system of equations, one way to check to see if you have a solution given a point is to plug that point back into the system, right? So for A, we're checking. So we're going to check that point. We're going to check to see if 4, -6 is a solution. So check to see if it is a solution. Okay. And how do we do that? We're going to look at putting those xy into each of those xy's. So let's determine that. So let's start with the first equation, 2x minus 3y equals 10. So in place of the x, it's going to be 2 times -4 minus 3 times -6. Does that equal 10 is the question. So I put in a -4 into the x, a -6 into the y, and do the math. So here we have -8 minus 3 times -6 is -18. And then when you have a minus and a negative, that becomes a plus, plus a positive. So we end up with from -8 minus -18 to -8 plus 18, which does, in fact, equal 10. So it works for the one equation. So now I got to check to see, does it work for the other one as well? So let's check that. So 6y equals 4x minus 20. So I want to plug that in as well to plug in -4, -6 in. So we're going to say 6 times -6 because that's the y. Does that equal 4 times -4 minus 20? All right, so if we look at this, this is 6 times -6 is -36. Does -36 equal, here we have -16. -16 minus 20. What is -16 minus 20? Well, -16 minus 20 is the same thing as -16 plus a -20, which is -36. So sure enough, they do equal each other. So that also works. So since both equations work for that point, we would say that Hannah is correct. Okay, so Hannah is correct, right? That point works for both. So now let's check B. Let's check Wirt. So Wirt is wanting to know, he's saying, is 2010 a solution, right? That's what we want to know. Is 20, 10 a solution? So let's check that. So the equations again, 2x minus 3y equals 10. That's one of them. And the other one is 6y equals 4x minus 20. So again, this is my x, this is my y. So we plug in for the x. So it's 2 times 20 minus 3 times 10. Does that equal 10? So 2 times 20 is 40. 3 times 10 is 30. 40 minus 30 does equal 10. It checks out. So let's check it over here. So 6 times 10, right? I'm putting the 10 in place of the y. Does it equal 4 times 20 minus 20? So once again, we look. 6 times 10 is 60. And then 4 times 20 is 80 minus 20. So does 60 equal 80 minus 20? It does. So Wirt is also correct. Interesting. So let's continue on. And they're going to ask us another question to get us to dig into this a little bit, and I'll talk through. So it says, what do the answers to A and B tell you about the lines in this problem? Well, remember, if I have a system of equations, the solution to the system is normally where those lines cross, right? The solution to the system is where those lines cross. And how many times does a normal set of two lines cross? They normally only cross once. But in this case, because that point works and that point works, so it crosses at both of those points. So what does that tell us about these lines? If there's multiple solutions, then these lines have to be what? The same line on top of each other. So wouldn't that be true? And in fact, to determine that, if we look at this, if I take this equation, let's take this one. Take this equation and divide everything by 2, right? So if I divide by 2, divide by 2, divide by 2, I'd end up with 3y equals 2x minus 10. And so if we look at that, now we can see that this 2x minus 3y equals 10 is the same equation as 3y equals 2x minus 10, right? If I were to rearrange and let's say solve for y over here, subtract 2x from both sides, divide by a negative, I'd end up with the exact same. They are the exact same equation. Therefore, they are there are infinite amount of solutions. So both of these would work, and there's going to be a whole bunch of others that would work as well. So what does it tell us? We would say the lines are the same. All right, hope that helps.